The object shown is in equilibrium. We want to find the magnitude and direction of the frictional force. We can now consider the forces acting on the object. We have the weight 10G acting downwards, the normal reaction force, which is perpendicular to the surface. We can resolve the weight so that it is perpendicular to and parallel to the surface, 30, 60, 30. So this one will be 10G cos 30 degrees, and parallel down the slope we will have 10G sin 30 degrees. The frictional force I will place here acting up the slope, but if it actually acts down the slope, we'll just get a negative answer. So actually putting the friction on the diagram in the correct direction is not really important. We can now ignore the weight force since we have its components, and the components will have the same effect. We can look at the perpendicular components, although they aren't especially important to us in this question. And we must have that R is equal to 10G cos 30, since the object is in equilibrium. Looking parallel, we must have 100 plus Fr, the forces acting up the slope, equal to 10G sin 30, the force acting down the slope. The friction is then going to be equal to 10G sin 30, take away 100, so it's 10 times 9.8 times the sine of 30, take away 100, which is 49 take away 100, which is minus 51 newtons. The minus indicates that we got the force in the wrong direction on the diagram, so our frictional force is 51 newtons down the slope and not up the slope as originally drawn.